All right, good morning, everyone. I hope you've all had a nice break, and thank you for joining us for the second session of the Canola Discovery Forum. My name is Chris Manchur. I am an agronomy specialist and research lead with the Canola Council of Manitoba, or Canada, and as well as your chair for this session of the Future of Field Crop Research. This session's speakers will be covering different forms of on-farm research and hopefully give us an indication of if we're going down the right pathway or potentially inspire us to move in new directions. We will not have any Q&As directly after the presentations, so please save them for the panel at the end of the discussion. In the meantime, I'd like to remind everyone, both attending virtually and in person, our Slido polling option. You'll find the code on the screen as well as on your name card. Just take a photo of the QR code around that green circle on your tag. Now, to introduce our first speaker joining us for our live virtual presentation, I'd like to introduce Aaron Mills, a research scientist from Agriculture and Agri-Food Canada out of Charlottetown, PEI, who will share with us the yen effect on cereal production in the Maritimes. Please welcome Aaron to the screen.
Thanks, Chris. Can you hear me?
Sounds excellent.
Okay, great, thanks. Okay, and you can see my presentation okay?
You are good to go.
Okay, thanks. Okay, so I'm just going to turn my camera on here just so people can see what the real Aaron looks like. I was pretty disappointed that I wasn't allowed to make the trip to Saskatchewan. I was lucky enough to be there last year for the Top Crop Manager Conference. And I like Saskatchewan quite a bit. I like Saskatchewan, but unfortunately, this is the way things have to go today. But I'll do my best. I'm always better in front of a crowd than I am talking virtually. So bear with me, and we'll get through this together. Okay, thank you very much. Okay, so I've been in contact with Jay Wetter and Jason Castleman, and they're interested in this yen thing that we have going on out here in Eastern Canada. And today I'm just going to talk to you a little bit about the experience that we've had setting it up and where we hope to take it in the future. Okay, so I'm hoping, there we go. Okay, so firstly I'd just like to acknowledge the people that are part of this thing. Honestly, we wouldn't be anywhere without the farmers participating in this and, you know, agreeing to be the guinea pigs as we've gone through this whole thing. Steve Howard has come on recently as the coordinator of the whole program. We have Caitlin and Dave who are working in New Brunswick and Nova Scotia to help roll this thing out. Kirsten has put in a lot of time hammering out the model with Marquisa. She also works on the reports. And then my crew, Christian and Sylvia, help with the processing. And finally, last but not least, Sherry Fillmore is our statistician down in Kentville. And she's really helped us put perspective on the data that we're collecting for this. Okay, so really, just to kind of give a little bit of background, we do quite a bit of on-farm research out here, and this is totally under the Atlantic Grains Council. And we decided it would have been maybe 8 years ago that we would essentially we were creating all these replicates within the farmer's field, massive hassle, and what we ended up doing was we moved more towards a site year system, and I think some of the speakers later on are going to talk about the importance of replication within the field. But when we look at variability for on-farm research, year carries the highest amount of variability, followed by site. And can we get the content to be in the main screen? Let's see if we can switch this around.
We can see the content just fine on our screen.
Oh, you can? Okay.
Yep, looks all good.
That must be somebody virtually, eh?
I'm not too certain, but you can just continue.
Okay. I'll leave it to the tech guys. Okay. So what we moved to do was to just focus on evaluating site years of data and not worry too much about the replicates. And the single fields themselves would be the replicates. And the only major disadvantage to this is that it takes a really long time to start generating meaningful data. The major advantage is that we have a lot of power in our analysis of the data that we put into this. So really, what we opted for with our on-farm research was, the good and cheap, and it wouldn't be fast. But at the end, we're coming up with some really cool recommendations that we can roll out to farmers to help them make management decisions. And we've had this approach, like I said, at least 8 years, a little bit longer than that. And we've gone in where we're looking at either a whole field or a split field, but collecting data from a whole bunch of fields through time. And one example of this is our soybean seeding rate. We have over 200 site years for that right now, where we're actually able to dial in the seeding rate recommendations based on the particular rotation that the farmers following. So I went to a conference in the UK. I met up with the Daniel Kindred and Roger Sylvester Bradley, who were doing similar things in the UK. And we got talking, and as a lot of good things are discussed in the pub, they were telling me about this yield enhancement network that they were rolling out. And it's essentially a yield competition. Now, yield competitions are nothing new. We found some evidence of yield competitions in the 80s here. I'm sure they happen all the time in Western Canada. But the godfather of the yen is Dr. Roger Sylvester Bradley. And I have a picture of him right here. And he came up with this yen approach. And here's a shot of our yield competitions from 40 years ago. And the main difference with the yen awards and the yield enhancement yield competition, we do award prizes, gold, silver, and bronze for whoever harvests the most of whichever crop we're measuring. But we also calculate the best percentage of potential. So that's essentially the farmer doing the best with the cards that they are dealt for that particular field. We've also started awarding prizes for the best nitrogen use efficiency, which is the way we calculate this is a very coarse method, where we look at the kgs of grain produced per kgs of N that were applied. But we're building in some other GHG related elements to this process. So really, again, this is what it looks like. We have our farmer collaborator, and they allow us to get into the field to do the sampling. We're asking for a grain sample right off the combine at harvest. And then we're asking for the management information for how they got to the yield that they did. The Atlantic Grains Council, they're pivotal in helping with the recruitment. They provide IT support so farmers can enter the fields themselves. They contract all the researchers in the other provinces to help with sample collection. And then the award ceremony and any of the tech transfer activities that might happen. And then AAFC, we've got a lot of all of the tools for processing the samples, soil, plant tissue, any of the 1,000 kernel weight test weights. Everything's fairly automated. We also do a lot of the analysis, data management, all of the modeling, and we do the report generation at the end. So this is what the typical yen looks like. Recruit the farmers. Basically, anybody can sign up their fields. At one point, we were looking for their best field and their worst field so that we could get some variability in the data. We identify those fields early in the spring. We collect the plant and soil samples. At the end, we're looking for a verified yield. Everybody gets a report, no matter what, but only the people that have provided an independently verified yield are entered into the competition. We collect the management data, model the potential yields, write the reports, and then present the awards. So each one of these steps, we can break it down. I mentioned the Atlantic Grains Council was key in helping us recruit farmers. That happens, I think this was our 2022 map. So you can see we have a pretty good spread. A lot of people are asking, well, what's going on here? But when I show you where agriculture is conducted on the East Coast, and you'll know why there's nobody there. The next process is actually getting into the field. We collect these grad samples where we're measuring plant length. We're doing biomass calculations. We're looking at seed size, and then we do a breakdown of the tissue, the nutrients in the tissue, and the nutrients in the seeds as well. And we do the same with soil. And that's these folks here give us a huge hand with collecting all of the data that we need to collect. We're currently working on an app to be able to enter this so the farmer can enter the data directly. But right now, this is a major cash herding exercise, especially when we get into the fall and guys are focused on getting potatoes out of the ground and they don't really want to talk to anybody at that point. So really, this is a huge part of what makes CN so great is we're using actual farmer data. We're collecting samples from their fields. And then we hand things over to the modelers. And the modelers are key in that they give us an idea of what the yield potential should be for each one of those fields. The initial model was based on the UK. AHDB is the commodity board in the UK. And based on their benchmarks, they used a relatively simple growth model that was based on light interception. It was based on precipitation, soil depth, which is kind of key. You see it, actually, they modeled it down to 2 meters below the ground. And they come up with essentially what the ideal crop would be given the amount of solar radiation, water, and some of the soil parameters are. And we found that it is a relatively simple model, but we found that it didn't really capture some of the things that are important about being Canadian, like snow, winter, frozen ground, things like that. So we found that the model estimates they were a little bit on the lower side of what was achievable by the farmer. And that's where we decided to move to some more sophisticated models in-house, where our modeling team is using what's called sticks. And we measure all of the parameters that were in the UK model, but we're able to throw in a bunch of different variables and come up with different scenarios. So if you look at the blue lines here, these are the actual yields, and they're sorted in rank, essentially. The orange is the inputs from just the light precip, and you can see they're not quite as close. They're a little bit all over the place, and then we can actually add a management layer with the sticks model. And we're in some cases these growers punched above what was deemed possible by the model. So it's a little bit more accurate, and it gives us a lot more power going into the future here. We generate these maps where these areas in color are only the agricultural areas. These are the only places where crops are grown in the Maritimes. These were the yields that we're looking at. So just so you know, our farmers here measure yield as metric tons per acre. So I had to go through and change a bunch of stuff to bushels per acre. And in this case, I didn't end up doing it. And then here's some of our yield potential for winter wheat, I believe, from 2023. Okay, so we pull all this data together and we provide the farmer with a report for every single field that they entered into the yen. And in this case, this guy helps out with he's new to farming. I don't think he'd mind me sharing his report. But we list all of the, essentially the tombstone information from the field. We have the winner's yield for this particular crop. We give the rank, and this is the person's yield. And then we just break down essentially everything that we measured. We provide it back with a little bit of information for the farmer to use going forward, and they can use that for their next crop. And then finally, the part that everybody likes is the awards ceremony. Just checking out my time here. Okay, all right. So the award ceremony, usually held in a pub. I just wanted to go through some of the results. I think these are 2023 results, actually. Just to give you an idea of some of the yields, they're quite respectable yields. I have to say these guys are really trying to hit it out of the park. Camden, obviously a popular variety for the yoke growers last year. The spring wheat, we have some diversity in the varieties that were chosen. And this is, I just wanted to highlight that, the top three for overall yield, we tend to see the top three the same for the percentage of the potential as well. But in some cases, we get them in different orders. So, this guy, he got the highest yield, but he wasn't quite as efficient as he maybe could have been compared to this guy. These are barley yields, and I mentioned we're starting to build in a nitrogen use efficiency. So this particular grower here, he was able to get 59 kgs of grain per kg of nitrogen applied. Esma is a European variety, malt barley variety. I think some people are calling it a petite barley variety as well. But anyway, we found that the European varieties do a little bit better under rainier conditions here. Lodging's a massive problem for us, and we found by switching to these shorter European malting varieties, lodging isn't so much of an issue for us. And finally, these are winter wheat yields from 2023. So yeah, we're really moving things along. Here's some shots of the award ceremony, and this is the trophy that the farmer who gets the highest overall goes home with that trophy for a year, and we put a badge on it. One of the most important parts of the yen is the grower panel. So after the awards ceremony, the next day we have our grains and oilseeds symposium. I guess it'd be similar to Canola Week, but just for grains and oilseeds for Atlantic Canada. And we'll pick the growers that did the best job and nobody likes standing up or sitting up in front of a crowd, but this is a really important part where the audience can ask questions, and we just kind of essentially talk out how the season went, things that we're doing that could be helpful, and things that weren't so helpful. Okay, so what have we all learned from yen so far? So we initially started in 2018, and so 2019 was our first year. 34 entries, we're up to 150 entries. The first two crops, it was just spring wheat and winter wheat. We added barley, and then we added oats here. We played around with soybeans. Soybeans are officially part of it, and then some crazy person suggested we put corn in there. I'm not sure how corn's going to go, but the really interesting thing for me is that we've seen the management complexity increase through time significantly. So this is the original winner. It was a spring wheat variety. And these are pretty much, this guy's a high baller, no doubt. He knows exactly what he's doing. But the spring wheats yielded the winter wheats this first year. And then this is what we're looking at for 2023, where, we're seeing quite a bit higher sophistication, more products, more applications, and essentially just trying to focus as much as they possibly can on yield. This is our the blue line, our Stats Canada data for winter wheat yields in Prince Edward Island, and I started working for AFC in 2011. The orange line is the average yen growers, their yields, and they're easily 20% higher on average than the provincial averages. And some of the really interesting, we used to plant our winter wheat based on a date, essentially, a cutoff date, which was largely dictated by crop insurance. But really, what we found was the single most important factor for us was early planting. And you can see here that we're always going to get these higher yields if we can get it in first 1 or 2 weeks after Labor Day. This is our seeding rate, relatively moderate seeding rate. What people tend to do is, if they have to push it later, they'll jack the seeding rate. And really, there's no getting that yield back. It's totally a time thing. And the yen data is glaringly showing us this effect. You can see it here with the plant population. Blue is winter wheat, red is spring wheat. We are seeing a bit of a yield bump with an increased seeding rate with our spring wheat, but with our winter wheat, chances are these guys are the guys that are planting a little bit later, and they're really not realizing the returns from those higher plantings. So we're getting up there. We're able to just with our wheats primarily and some of our barley. We're able to build some really sophisticated statistical models, and we're able to identify some of the factors that have the most effect on yield in the region. Variety is actually one of those things. So the Atlantic Grains Council looks after the variety registration similar to the Western Co-op research trials. We didn't see a whole lot of diversity in the varieties, even though we do have quite a few available to us early on. But what the yen's done is really improved the uptake of some of these newer varieties, and growers are seeing it as a higher value proposition to invest in certified seed. Speaking of which, we track whether they're using certified seed or bin run seed totally anonymously, and we're really seeing a strong trend towards higher yield in every single crop that we're measuring with certified seed versus safe seed. So this is something that we're just trying to encourage the growers to do. Another tech transfer aspect that we're using is looking at the top 20% versus the bottom 20%. And this really hits it home for a lot of growers. The idea of building our biomass early on, the fact that barley can really respond to nitrogen and give us that yield, especially in a rainy day, or a rainy season, as long as it's not laying down, and the seeding rate is not so important with the barley. And these are just some other aspects that we tend to go into more detail. We have a lot more information that we're sharing with growers, but this is just to kind of highlight some of the big differences between the top 20% and the bottom 20%. We also have some spin-offs from yen. So I'm running out of time here, so I'm just going to kind of go through this. We were seeing an increase in a lot of these products that were added to either the as a tank mix for herbicide or fungicide. And so in my own program, we decided to put a lot of these to the test. So we've got, this is what it looks like. We're looking at 3 different types of fertility, but we've got all the herbicide tank mixes going left to right, and then we've got all the fungicide tank mixes going bottom to top. And you'll see a lot of these companies will give you the data on their own products, but they won't test their products in combination with the other company's products. So as part of the yen, we've set up this checkerboard where we're measuring everybody's products in combination with everybody else's products. And you can see in a lot of cases, these products are better than just the straight up control, no matter what the underlying fertility is. But there are some benefits to using different companies' products in combination with other products. So where are we going with all of this? We are interested in GHG sampling for 2025. We're hoping to roll it out for 2024. Just essentially choosing some farms to give us an idea of this. We have built in some economic analysis, and we want to tie the GHG sampling in with some of the economic analysis as well. Soybeans I think we're up to 20 or 30 fields this year. And we're also building in more dawn work, some soybean root modulation work, and these are our modelers that work with us. And I think I'm pretty close to being on time there. We're building more collaborations with Ontario. They picked this up a few years after us. They do things a little bit differently than us. I think we have some stuff to learn from them, and they have some stuff that they can learn from us as well. We're talking about a trip together to the UK to visit some farmers over there and experience some other farming cultures. We really want to try to add more value to the yen. I mean, for me as an agronomist, it's really exciting to get a lot of the agronomic metrics. We want to build in more of the economic metrics, and does this pay? What can we do to improve the bottom line? And right now, yen is fully funded by the Atlantic Grains Council using checkoff dollars. We really need to figure out how we can add more value so that people are going to want to pay to be part of the yen as they do in the UK. Okay. Thank you very much.
Thank you, Aaron, for the excellent presentation, and also for joining us over 3,000 kilometers away to chat with us. And we'll look forward to answering a bunch of questions I already see on Slido at our panel discussion, so please stick around for that. Next, we'll have Jocelyn Leidl, a graduate student at the University of Saskatchewan and Research Program Manager at MNP. Her presentation is on the on-farm evaluation of nitrogen response in canola, systematic design versus traditional randomization. Please welcome Jocelyn to the stage.
Okay, so I'm Jocelyn Leidl. I am currently finishing up my master's under the supervision of Dr. Steve Shirtliff here in Saskatoon. But recently in August, I took a position as the research program manager at MNP, or more previously known as Max Ag Consulting in West Central Saskatchewan. And today I'm going to talk about a part of my master's research, just about on-farm evaluation of nitrogen response in canola. comparing systematic designs to traditional randomization. So just a brief introduction. So there's various different types of agricultural research methods for different trials depending on your goal or number of treatments that you have. In on-farm research, yield monitors often fail to account for large yield differences, and plots need to be at least 121.9 meters long in order to estimate or accurately estimate the yield of that plot. Randomized complete block design trials, or RCBDs, are commonly used in research stations, and they're usually done on the small plot scale, but they're often placed in the most uniform areas of the field, and this often fails to account for overall field variability that a producer would be dealing with, so it's not accounting for the overall topography of the field or different soil textures. And RCBDs can be difficult to accomplish on a field scale level because they take up a lot of space, a lot of advanced planning is needed, and producers are not willing to vary their inputs over the wide range. Strip trials, if they're not replicated, it can be difficult to determine if you're actually dealing with a treatment response or if it's something environmental that's occurring. So, with all that being said, the proposed methodology of my research is called Modulated On-Farm Response Surface Experiment, or MORS for short, and this is a systematic or applying the treatments in order over larger land areas. So I have two experimental objectives. My first one is just comparing the MORS design or the systematic design to a traditional RCBD, and this is done on the small plot scale. And then my second objective is just utilizing UAV imagery to extract normalized difference vegetation index, NDVI, and normalized difference red edge index, NDRE, to determine how many days after planting and at what crop stage best correlated with yield. So some brief trial details. I did my field seasons in 2022 and in 2023 at the Kernan Crop Research Farm here in Saskatoon. There was 11 total nitrogen treatments ranging from 0 to 310 kilograms per hectare of nitrogen applied. And the reason why we have such a low rate and such a excessively high rate is just so we can get the entirety of the response curve. There was 10 replications of each experimental treatment. So there was 10 of the MORS and 10 of the RCBD. And the equipment that was used was a variable rate applicator on our seeder, which was capable of automatically varying our 11 different rates of nitrogen, as well as a Zern small plot combine. Both the combine and tractor were equipped with a GPS. And this allowed us, if I show the next slide, if you see the aerial photo on the right side, there's no gaps or breaks between the reps. And this is because it uses the virtual plot design, so we know where the plot started and stopped, so we can allow them just to be continuously seeded along as we use the different rates. And this will increase our amount of replication, that's why we can have so many reps, and this in turn increases the statistical power of our analysis. Looking on the left side, this is the plot map. So all my plots looked like this. I had 4 sites in 2022, and then I had 6 sites in 2023. But for this presentation, I'm only talking about the canola. It was also done in spring wheat. So the blue passes are the MORS design, and the yellow passes are the randomized design. And you may be thinking, what is the big difference? If you look at the first pass, we start off with a treatment 3. And then it goes back up 4, 5, 6, all the way up till 10, where then it goes back down 0, 1, 2, whereas the yellow passes have all of your treatments randomized throughout. So the statistical analysis that I did, I used a general additive model or a GAM model because this model could really fit the nonlinear response of nitrogen response trials because, of course, plants can only take up so much nitrogen that will have a yield response until they can't take up anymore, and then we'll either hit the constant value until it eventually plateaus, which actually happened in 2023. My nitrogen did get toxic to the plant, so I had decreased plant emergence in some of my sites and had to get rid of them. But in this model, I used yield as my response variable and treatment as the explanatory variable, and p-values were considered to be significant if they were lower than 0.05. So here's some results. These are the yield results from one of my canola sites in both 2022 and 2023. This is on the exact same field location. It's called the Nasser quarter at the Kernan Research Farm, but this site's actually kept specifically low in nitrogen, so it's really good 4 nitrogen response trials. I think the nitrogen levels in this site were about 9 parts per million compared to about 30 in the top 6 inches of soil at my other site, which is called the Hunter site. But comparing the two designs here, the Morse design is shown in red, and then the randomizer RCBD is shown in blue. In 2022, we had very similar responses to the different nitrogen treatments, and then in 2023, again, we had more variable results, more variable crop emergence just due to lower rainfall at the time of seeding, so it's a little bit higher standard error, which is what the shaded area represents. Looking at the standard error further, so I use standard error to compare the precision of the Morse design to the RCBD. So we're not trying to see if the Morse design is better than an RCBD, we want to see if it's comparable. Because when producers are going to be applying this on farm, it's easier for them to apply it in order than trying to go through and randomize. You deal with different issues that may arise. And also with harvest, you're going to be able to pick up on the differences in yield more effectively on your yield monitor because you can actually see the increase or the decrease in yield instead of if your treatments were randomized, it would just give you an average. So you're not going to see that increase or decrease. So in 2022, between the Morse and the RCBD, we had a very comparable standard error, which was awesome to see. And in 2023, the Morse design did have a little bit higher of a standard error, which we just concluded that was just due to the lack of randomization. Of course, randomization helps to lower your standard error, but the difference was very minimal, so they were found to be pretty much as precise. So now you may be thinking, why 10 replications? No producer is going to actually do 10 replications. And what I've learned from my few short months with M&P or MaxEg is that producers, it's hard enough to get them to do multiple reps, let alone 10 reps, and you're not going to have enough space in a field to do 10 replications. So one of the sub-objectives is just to see at what number of replication would give you the most constant standard error. And this was found to be at about 4 to 5 replications, which most of the trials that we did at MaxEg, we had 4 replications. So that was nice to see that that's all, being done. Of course, with higher amounts of reps, you have lower standard errors. Taking that one step further, this is just the nitrogen response, or the yield response to nitrogen, looking at each individual rep. So these are all 10 replications, break down between 2022, the same Nassar canola site, and then 2023. In 2023, there's more variable results, but this is just more so to see, you can see like where the nitrogen became toxic and you actually got a lower yield in your higher nitrogen rates. Aside from all of my in-field data collection I also had my plots flown weekly and bi-weekly using a DJI Matrice UAV by a member of the Agronomic Crop Imaging Lab. After this was done at the end of the season, she stitched all of my images together. There was about 1,000 images to form one orthomosaic. Then I got the orthomosaic images, put them into QGIS where I extracted NDVI and NDRE values from each plot. What makes that important? So basically, if you take the different NDVIs and NDRE values, I took them after harvest and correlated these values with the different yields that I had gotten at harvest time. And you can actually see the black line is NDVI and the correlation value or the R value with yield. And then the gray line is NDRE. So the Hunter canola site is shown here. I haven't talked much about it, but these are my 3 canola sites I had throughout my master's project. The highest correlation I had was between NDRE and yield in most of my sites, except for the Hunter canola site did have NDVI with a higher correlation. And this was actually at about, most of my stages was at potting. In the wheat, it was at heading. But as you can see in the Nassar canola site, it was actually at like the bolting stage in canola before flowering. Looking at this one step further, in 2023, my highest correlation value was 0.81. So that was a very high correlation between the two. My wheat actually had higher correlation values, but we're not talking about that today. And my p-values were very significant showing a very strong linear relationship between the yield and the UAV NDVIs. I had a higher correlation, like I said, of 0.85 with the NDRE indice, as well as a strong relationship between yield and this variable. So why is that Why is all this important? So in conclusion, the systematic design, or the Morse design, was found to be as precise as a traditional RCBD when we compared standard errors. As well as on-farm research, like I said previously, it's easier to apply treatments in order for producers, because this can allow them to be more easily shown on yield monitors, as well as more easily applied. Why were the vegetative indices important? It actually allows us to see what rate is doing better before we've even combined the trial. So I could have went and took those dates and saw, oh, yep, the most ideal rate was 104 to 132 kilograms per hectare without even combining my plots that year, if I would have known what stage to go out and fly the trial. Potential future work. So these are some photos from my farm. My brother wanted to be included in this presentation, but so that the next steps of this trial, it was done in, there's a fungicide rate application that was done alongside when I was doing my master's. I just didn't do it because we had 2 dry years, as well as other members of my lab did it with different phosphorus rates, as well as other quantitative measurements like seeding rates you can do it with. Now, I believe this year was my year I didn't have a field season, but Steve has moved it to the on-farm scale, and they're dealing with analyzing all that data, so be getting that soon, and obviously the next student will be working with all that. Yeah, so with that, I would like to thank all my funders, SaskWheat, SaskCanola, and the Western Grains Research Foundation, my lab, the Agronomic Crop Imaging Lab, the Kernan Crop Field Crew for all their work seeding, spraying, combining my trials. All my graduate student friends, I didn't show the results from this, but I had 220 plots to count and 4 sites in 2022 and 6 sites in 2023, so there was a lot of counting that needed to be done, so I had a lot of friends to help me. And I'd also like to thank all of my coworkers and the customers at MaxAg MMP for just showing me all of the real world problems and issues and how on-farm research is actually applied, which really helped me with this project and finishing it up. And yeah, thank you.
Thank you, Jocelyn, for the great presentation. Next, I'd like to welcome Kayla Slind up to the stage. Kayla is the lead research associate at the Western Applied Research Corporation, or WARC. And the title of her presentation is From Trials to Triumph, Effective On-Farm Research with SaskOilseeds Top-Notch Farming Program.
Okay, thank you. Yeah, so my name's Kayla, and this is going to be a bit more tailored towards the agronomists and the producers, a little less scientific-y, and more just about how I run on-farm research with the SaskOilseeds new program. Sorry. So, in the next 10 minutes, I will tell you about the Top-Notch Farming Program, how I lead an effective trial as project lead, how agronomists can effectively oversee a trial, and why the Top-Notch Farming Program is effective. So in 2023, SaskOilseeds started their Top-Notch Farming Program. The goal of their program is to actively seek input from farmers and agronomists to shape future projects and cultivate a collaborative network between SaskOilseeds, farmers, agronomists, and research specialists. While separate, they work in collaboration with Sask Barley, SaskWheat, and the Saskatchewan Pulse Growers, each with their own on-farm program. So the way that the Top-Notch Farming Program works, as long as with the other commissions, is you have SaskOilseeds at the top, and they fund the trials as long as help with protocol development. Below them, we have the project lead, which all commissions did contract work this year for the project lead. So we oversee, coordinate with the agronomists and producers, we analyze the data, and we write the reports. And next you have the agronomists, they're the boots on the ground, they're collecting the data, they're working with their producers. And then last you have the producers who use their own equipment, their own inputs, and they use their own fields so we can get some real field results. And then other than what the treatments is we're looking at, like let's say a canola seeding rate, everything else is how they would typically farm. So if it's a canola seeding rate trial, their fertility, their pesticide applications, that's all what they would typically do. So as project lead, the main ways I try to lead an effective program is just, it's relatively simple. It's communication and organization. Throughout the year, I'm in frequent contact with agronomists and producers. And then at the beginning of the year, before seeding, I do supply with an Excel document. It's nothing fancy, but as we all know, there's so many different softwares and programs out there. What we have found works easy is just keep it simple, Excel, and then they can input their technology into that. So it's all the same between sites. So within this document, I include very many data sheets, including maps, calculations, and anything else they might need to carry out the protocol. So here we have the canola seeding rate trial, where I supplied the agronomist a map with the seeding rate calculator, just making sure we're all on the same page. I also provided individual sheets in the Excel document for each data collection required. And then here we have the plant density and yield as an example, where the treatment numbers and treatment descriptions are all the same, and it includes the necessary calculations. So next is your trial manager or your agronomist, and it's very similar to project lead. So similarly, how to be effective is to communicate and be organized with your producer. So this year I was also an agronomist for 13 sites, so I do have a little experience here. So, as an agronomist, I made sure to use those data sheets, and I also sent them along to the producer. So, for example, back to the seeding rate trial, the seeding rate calculator was provided, so I made sure you input your producer's TSWs and target plant densities, then you got your pounds per acre. Once you have your pounds per acre, update your map, because when they're in the field, they don't care what seeds they're aiming for. They want to know what they need to set their drill at for pounds per acre. Or, depending on what technology you utilize, write them a prescription map. So, whether it's for yourself, the producer, or even some of your coworkers, create maps that show where the trial is located and what each plot's treatment is, so you can be confident in your data collection throughout the year. So here you have just a simple map I created using Google Earth, nothing special, it's definitely not to scale, but it correlates to the map on the data sheet. So if I had to send out a summer student and I wanted to make sure they knew where the trial was, where plot 1 was versus plot 12, I felt confident that they knew what was happening. Also, I was provided this from another agronomist. There's the prescription map, matching the map layout on Word. So these are all great ways and relatively simple ways to make sure everyone is on the same page and we know what's happening. So yeah, as I mentioned earlier, throughout the growing season, things change. We all understand what it's like to be in the field at the moment, but myself, my team, the other agronomists, other coworkers, we don't know what happens, so therefore it's really helpful when agronomists update that data sheet by ensuring all areas, not just the main map, but if it's your plant densities, your yield, make sure all of those correlate and are the same. So here you have the yield data sheet, has the treatment numbers and description matching your field map. So this allows myself and my team to have the confidence in the data that is provided so when we analyze it. Because as we're going through data this year, there's some pretty interesting results that we don't always have the most confidence in, so it's nice to make sure that it all matches so that we can have that confidence that even if the numbers are maybe a little odd, that there's possibly a reason for it or it's just what happened, that there's not a mistake. So lastly, I will touch on why top-notch farming overall is a really effective program. So one reason is because producers replicate and randomize their trials. So here you see the map looking at nitrogen rates and Envita. We ask that trials be replicated at least 3 times, 4 is preferred, and this is to account for any field variability or if one area of the field has some issues. So 3 reps are needed for statistical significance, therefore we ask for 4, just in case something happens, we still have usable data. So here we have rep 1, rep 2, and rep 3. And within each rep, we have each treatment 1 time. So here, treatment 1 is the full rate of nitrogen with no Envita applied. Here, you'll see it in rep 1, 2, and 3, and this randomization throughout the field helps mitigate any variability. So then once the trial is harvested and I have all the data, which all correlates and matches up, the WARC team can analyze it. Jessica Enns, our research manager, is the brains behind the actual statistical analysis. I just get it all set up for her. So to start, I format all the data for Jess, and then she puts it into her stats software and everything, and then she runs it, she lays it out for me, and then I can put it into graphs, charts, and then I summarize it. So the statistical analysis is different for every trial depending on the parameters, And this analysis allows for confidence in results and determines if differences were a result of the treatments or not. So for each protocol, information on how the stats were conducted are included to ensure that everyone can get the most out of the information. And then another way top-notch farming program is effective is by providing results for each individual site, so the producer can see exactly what happened on their farm along with the other farms participating. So here's an example of an individual site report that was in the 2023 on-farm results booklet. So here you can see at the top left, you have the title, the farm that it was located at, along with treatment lists, weather, agronomic information, results, summary, and economics. And along with, at the bottom right, you also do see the logo of the agronomist that provided support throughout the season. So next, we also analyze and write combined reports. So this means we take in consideration all data from each site participating in the protocol. So here's an example of all nine sites' data combined for the foliar applied nitrogen fixing biological products in canola in 2023. So this is extremely valuable as it gives information and results throughout the province from multiple locations. And then another bonus of participating in the top-notch program is that producers and agronomists who participated are invited to a results banquet in Saskatoon hosted with the other Sask crop commissions. So at this event's results will be shared for the first time, and attendees will receive a booklet containing all the results from every program. So by participating in one program, you have the opportunity to hear results from all the programs and get a book with all the program's results. So also, as a token of appreciation, the commissions will cover producers' hotel expenses for that event. Agronomists are compensated for their work throughout the year. And overall, the hope is for producers to participate because they're genuinely interested in the research and its potential benefit for their own farm and other Saskatchewan farmers. And lastly, being part of the network of producers and agronomists, all with the same mindset, with the same goals, is a really key benefit to participating in this program. So for 2025, the protocols for top-notch include seeding rates, split and top-up nitrogen, enhanced efficiency nitrogen fertilizers, boron applications, fungicide, and seeding dates. We are always looking for more agronomists and producers. And if you have any further questions, please feel free to reach out to myself or Kayla. Thank you.
Oh, don't go too far, Kayla. We got a panel discussion to happen. Okay, all right, well, thank you very much. And I'd like to welcome both Jocelyn and Kayla back up, as well as Aaron virtually for a panel discussion. We'll hop up into these chairs and we'll answer some questions from Slido, as well as I got a couple questions for you all as well. So. Okay, so, does it work now? Okay, good. All right, so I'm going to start off with one simple question, hopefully, and although it is a two-parter, and I'll have everyone answer it, and Aaron, you'll start with this, but with on-farm trials and data collection, what new technology or practice has enabled us to collect better farm data more efficiently, and what do you anticipate in the future to take us even one step further?
Yeah, I don't know that there has been a huge advancement in data collection technology. I know the yield monitors are good if they're calibrated. Not every farm is calibrated, and so it becomes difficult to pull all the numbers together. The drone work, it definitely, it shows promise. But at the end of the day, like, we're measuring yields out of a combine, right? So really, I'm not sure that, I don't know, unless we get robots or something, I don't know that we can send out to collect the numbers, but yeah, like, we're still really, we can automate the data collection, we can automate some of the analysis, but like, actually sample collection, I think we're still a ways away from improving that.
Yeah, I agree. Technology's great when it works. My technology for in-season data is summer students. So yeah, we keep it pretty simple. there's great technology, but yeah, with our farm programs, we're still using Excel and numbers, and yeah, if they have weigh wagons, that's great. We hope their grain carts are calibrated. If they have the variable rate and prescription mapping, great. Hopefully it works, but yeah, I agree with Aaron.
Nothing can beat boots on the ground, right? Jocelyn?
Yeah, okay. So, to add to it, I agree, obviously. Starting in August, I was only there for harvest, so I wasn't there for the entire field season for all that data collection. But one thing that really was helpful for getting samples and everything, we use Field View was really, really useful because it would actually tell you like how far, like how many acres you were actually going in the field, and you could actually see the prescription map and make sure that you're in the right plot, and if it veered off a little bit or something got a little wonky. Most of our producers also use variable rate, which makes it a lot easier. And then if they don't have field view, a lot of them had JD Ops, so that was very similar. You could see like how far you're going, see the prescription map. And then of course drones. Can't not mention that, being a part of Steve's lab. He's really pushing for using all the imagery aspects, and of course my project has that in there for the on-farm part. And yeah, grain cart scales, as long as everything's all calibrated, works great. Yeah, I do have to agree that technology, if it is not up and running, can be rough because there was a few little hiccups in the season. But overall, yeah, I think adding those.
Great. Okay, so I was watching Slido a little bit earlier, and I'm going to build on one of the questions there. And so we see a lot of, compiling a robust data set is very important to make some decisions into the future. And we see, say with the yen, the number of farmers really helps with that number of fields or site years. We see replication being important. And so is there any value in terms of having a single replication across multiple fields in a year? Or do we need multiple reps in a field to get some meaningful data? Kayla, do you want to start?
I can comment on that, because that's really, we shifted to using single field replicates for everything. And so it just ends, if you have to conduct an experiment, that's one thing. If we're testing one minor thing, then we can do our 3 reps or 4 reps or whatever, but the more sites you have and the more years you have, the more impactful your data is going to be, right? So if at the most, like we just found when we were putting more than 2 treatments in a field, a farmer is just going to walk away. They will help 1 year, they will not help 2 years. And so we just found that, it's the fields are different, but if we focus on collecting multiple fields over multiple years as a single replicate, that our data, it just ended up being easier to deal with.
Any other thoughts here? No? Okay. Well, let's go to Slido from the floor. We have a question from the floor. I don't know where mic runners are.
I don't see it. Oh.
This is maybe a question for Aaron, but I was so encouraged when you say you have a sustainable model that you're trying to build, as well as you're going to look at greenhouse gas emissions, because I think there's a perception out there that the more inputs or innovation, that's going to have a higher environmental impact. And I know some of the work that we've done at the Global Institute for Food Security shows that greenhouse gas emissions is, the good news story from a Canadian farmer perspective is that it's an innovation story. So my question is around how are you going to measure sort of the greenhouse gas as you think about sort of 2025 and beyond, and make sure that we're really collecting that data in an important way to kind of continue to tell that great story of Canadian innovation and sustainability?
So I don't think it's any secret that, the more nitrogen you apply, the more yield you're conceivably going to get if you don't run into a bunch of issues. But, GHG coming off of fields is pretty much just the amount of nitrogen that you apply. And so where we have, you guys are largely no-till, if not exclusively, and we're completely the opposite. The no-till system. It doesn't really work for potato production. So my face is coming up, and I'm just seeing my face, which is a little bit disconcerting here. I'll keep talking through it, but yeah. So really, what we were going to do with the GHG measurement was just to. I mean, there's a lot of analogs for agricultural production and GHG emissions that are just essentially assumed based on the production strategies. But we were going to put, or we are going to put collars in sentinel fields. So we're going to pick, maybe 15, 20 fields across the region and do the weekly sampling. And just to get some actual data where we can start to put some numbers to the management approach. So, I mean, we don't want yield at all costs. We want sustainable yields. We want the growers to make money. We don't want them to throw the groceries at their fields just to hit the highest yield. So I mean, all of those things again is great. Not everybody who throws everything at their field is going to get a massive yield, and that's burned a few guys where they're just kind of indiscriminately throwing inputs at the crop. But we're kind of moving out of that now, and we're starting. I mean, the price of inputs helps quite a bit to help us decide what we're going to put into the field. But the whole notion of, and I know you guys do this, the yield targeting, we're not there yet. We've got a lot to learn from Western Canada in terms of what is our realistic yield, and really until the end came along and we're starting to calculate what the potential yield is for each field. It really wasn't. It was like, yeah, the more the better, and that's. I think we're starting to move away from that as well. I'm not sure if I answered that question, but it's GHG is part of our lives here right now, so we've got to measure it as much as we can.
Mm-hmm. Yeah. So circling back a little bit to the economic side of things, and I think, Aaron, you mentioned that there is a desire to put in more of an economic component into the yen in the Atlantic provinces there, but I'm just kind of posing the question here. Is there a desire to kind of integrate more of that economics angle in relating it to the extension of the results, especially when you take into, say, look, nitrogen responses or potentially in Morse? What do we think? We'll start with Jocelyn.
Okay. So there is, I guess, in our research program that I'm working with. I haven't got to cover it all yet, obviously just starting, but we do look into like the economic side and like what seeding rate would be more economically beneficial for producers or what product. So one of the things we did was like a canola variety trial, and one of the varieties costs significantly more than the other one, so you really have to take that into effect. But like certain things, like if you're doing like the yield targeting, you really have to know your field. Like you can't target a certain yield and just expect it to happen if you're dealing with like a sandier field location. It's just not usable. So one thing that we also do with work is we kind of break up the field into different zones. So there's different zones based on the different landscape in the field so that you can target specific yields and put different rates based on those zones in the field instead of just like blanket, just hoping to get the same yield for it all. So, yeah.
Yeah, and similarly, for the Top Notch and the other Sask crop on-farm programs, that for each site and even the combined, we do take like the yields and we do the economics. A lot of it's just like for we kind of keep it pretty simple because economics can sometimes be a touchy subject with some people because there's so many different ways to look about it because some guys value their time different, or like the fungicide trial I did one in wheat and we're looking at it for canola for next year, and for the economics it's simply the cost of the fungicide per the 2024 Government of Saskatchewan guide, but that's not including your sprayer, your fuel, your man hours. So it's economics can be difficult. You could really dive into it, or you could keep it pretty simple. For this year, we are keeping it quite simple. We're hoping to expand on it and get down to the nitty-gritty, but yeah, economics is definitely important.
Great. I'm going to put a little spin on that for you, though, Aaron. Kind of inspired also from a Slido question, but what about the willingness for farmers to kind of open up their books, or openness to share the results now that you've had many years of this, and you also have that farmer panel? How does that go over?
Yeah, it was really interesting starting this out because, we brought the crew in from the UK and we started talking about, 20 tons per hectare, and all the farmers are in the room getting sweaty. Oh my God, this is going to be awesome. And then we dropped the bomb that, we're actually capturing more on-farm innovations and we're going to share it with everybody else. And really, I have to say, the older farmers, they've got it figured out. I mean, they don't really need to, a lot of those bigger yields are older guys who've been doing it for a really long time and paying attention. We find the younger guys are more into the sharing of the information. So all of our data, when we collect it and analyze it, it's all anonymized. And, I think as a culture, certainly on the East Coast, we're pretty nosy about what our neighbors doing. You guys probably aren't nosy at all, are you? But, everybody wants to know what the neighbor's doing. And so that's kind of the power of this approach, is that, this is what I got. I wonder what he got, and what did he end up doing? And that's how we try to bring it home with that panel. And I mean, it is honestly difficult getting farmers up there to talk about it, and that's where the whole competition side of things spices things up a little bit. We do find demographically that the younger guys are more into sharing this open source approach to improving their yields. Now, potatoes are our biggest crop, and we haven't been able to launch again on the potatoes. So, I don't know if that says something about the potato guys, but we're good on the grains and oilseeds.
Great, thanks. Are there any questions on Slido being asked?
One of the questions, Chris, to Kayla was, how do your topics or research topics get decided for the top-notch trials?
For sure. So of course, you all know SaskOilseeds run by a board as well as WARC, and we make sure throughout the summer we are speaking with agronomists and producers between the boards. Agronomists and producers, we kind of gauge and ask what their problems are, what they would like to see, and then we go from there. So we really try to make sure that the trials that we are going to do in the future are those that are truly applicable and of importance to the producers.
Great. Any questions on the floor over there?
This is for Jocelyn. Thanks. That was a really interesting concept. So I would like to know your thoughts around expanding this comparison to other crops and parameters. I know you mentioned towards then you're still working towards that. But so you compared it for yield, and yield is kind of throughout the season, all the variables kind of balance them out by then, and then that kind of showed up in your data and the closed standard errors between the two models. But do you have any early indications or your thoughts around particularly some early season parameters like disease maybe or emergence? And because I think this is really interesting concept which would enhance the applicability and the pragmatism side of expanding the research into growers' fields. So thank you.
So for this presentation, I only focused on the yield just because, producers are more, wanting to know about yield, more interested in it, as well as, the time constraint. I couldn't show all of my data, but my thesis did look at a variety of different things. I did plant counts for all my trials. It also, like I mentioned, was done in wheat, so that's another part of it. I also did NDVI ratings using a handheld green seeker throughout the season, and I correlated those with my drone NDVI values that I got. I also did biomassing. I did a bunch of biomassing on both crops. I then ground all of my biomass and did the different nitrogen concentration in both the tissue and then also in the seed, and figured out my nitrogen uptake levels. Then did yield. We did the proteins based on the protein in the seed that I did at using a LECO analysis. And then we also had an NAR sensor that was mounted on the combine. So I got proteins directly off the combine. That was just in wheat. It wasn't calibrated for canola. In terms of like other crops, I know when I had given this presentation or a similar presentation in March, that question came up, and Steve was actually in the room. So he was able to say just some of the next steps for it. They are doing it in peas. Another member of our lab, she did it in oats and looking at different phosphorus rates. Just.
Like, for the plant counts or biomass?
Oh,
or,
yes,
and
they were very similar. Again,
okay.
Yeah, like the standard errors across all of my parameters, they were very similar between the two. My plant counts, like I kind of mentioned, the rainfall, they seeded my trials on May 5th, which was pretty early for the canola, and we didn't get any rain for 2 weeks after that. So then I had really low plant emergence, and that's why we had to reseed 2 more trials. But looking at the results, especially from 2022, they were very comparable between the two.
Just one last quick question. So it's 10 replications, which obviously improve the statistical power of the data set. Would you think anything may change if you reduce the number of replications to widen up the gap between the two models, or?
Yeah, that, so I had my permission to write in June, and that was one of the questions that, if you know Eric Lamb, I'm on my committee, and he actually asked me to look further into the stats. I'm not sure if I will be going any deeper on that, if that'll be another student's area, especially when they do the on-farm, just to see if okay, now we know that the 4 to 5 is ideal. If we do this on-farm, is it actually 4 to 5? Can we go lower? Do we have to go higher? There's just more research that needs to be done with that, but probably isn't gonna be mine, so.
Great, I think we have time for one more question. Maybe we'll go to Slido for this one.
So there's a question that got a few upvotes here, and it's how do you statistically analyze yield data with 1 replicate per field for many, say, years?
Guessing maybe Aaron, do you want to take that one?
Yep, no problem. Yeah, so really, it's all about the mixed models analysis. So really, it takes, traditionally, you would be looking at essentially 3 or 4 replicates if you had 1 field for 1 year. But if you have multiple fields for multiple years, we like to be, my statistician and I, we kind of differ on this. She's okay with the 30. I like to have at least double that. But when you think of that, that is actually 60 fields, right? So that's a lot. Really, if you aren't measuring, it depends what you want to measure. So if we're breaking out sites, and we see it in CJPS all the time, you may have 3 locations, and you'll break it out into those 3 locations. Are you looking for the effect of seeding rate in location A, or seeding rate of location B, or seeding rate of location C during a particular year? Or are you looking for the best seeding rate? And so that's where we use mixed models analysis to kind of build in the years and the sites through that. And, like I said, it's 1 rep per field. Our fields are, we might have a 100-acre field, 200-acre field. One of our farms is probably the same as one of your farmer's fields. So, the scale is totally different. And we're able to get around some of the spatial limitations that you guys might have in Western Canada. But really, I mean, that's what mixed models were designed for, is pulling out the variability from sites and years. It's what plant breeders do, right? I mean, that's why plant breeders need site years in order to figure out what the best varieties are. So we just apply that to agronomy as well.
Great, thanks, Aaron. Well, I had a really good discussion with you all here today. And I'd like to thank Aaron, Jocelyn, Kayla for the presentations and the chat afterwards. And I think I'm the only one stopping you guys from lunch. And so buffet is just past that wall over there. And we'll see everyone here back at 1:00 p.m. sharp for the Challenges to Productivity and Profitability session. Thank you all again.